Dear students, welcome again. In the previous parts of this course, we developed our skills to understand the real systems in the real world and to make abstractions in order to create classes, to create entities, to create relationships between diagrams. And we make many exercises to project our system in DFD diagrams and in UML diagrams. In this video, we'll try to convert our diagrams in a database. We try to use always the same example in order to correlate the different parts of our course. We use the smart home if you want, or a connected home as I prefer. What is a connected home? We have different parameters that we want to measure in an apartment to understand the behavior of the apartment. We use different type of sensors. Some of these sensors are fabricated or designed by our laboratory, others are used. We bought them from the available market. We put all these sensors in different parts in the home. For example, this sensor that we fabricated ourselves, it is not really a sensor only, it is different type of sensors that are combined together in one embedded system, and it can measure temperature, humidity, luminosity, etc. We put it in different part of the apartment, and we have another type of sensors that we used. It is, for example, this one, it is open-close sensor that we put in the doors or in the window in order to detect if the door is open or closed. We have full water meters. We can put it in the general meter of the apartment, or we can put another types in the kitchen, for example, or in the bathroom. Also, we have electrical meter. We prefer to use wireless sensors and wireless adapters or modules that combine many sensors. These sensors send data to the Raspberry Pi, the small PC. We saw that before in the previous videos. And the inhabitant, for example, or the researcher, can communicate with this computer in order to understand what happened in the apartment. In the same time, we can communicate the data to a smart city system. We can collect the data from different apartments in the city in order to help to understand what happened in the city. Also, in the previous videos, we talked about SQL. We said that SQL, it is very easy to use because it describes what we need. We can write what we need, not how we will do it, because SQL is implemented in different database management systems. It contains 3 types of instructions, such as create table, insert into table, select from table, grant, revoke. The first family is to create the data and to add data. The second one is to search some types of data in our database. The third is to give rights to some users regarding their position in the system. I want to say that we may have different type of diagrams. We will try to be general in this presentation. For example, we have EERD. It is similar to class diagrams in UML, but there is some differences. For example, sometimes we prefer to use uppercase or lowercase letters. Sometimes we prefer to use primary key, foreign key symbols. We can add them in EERD, but the logic is the same. For this reason, you can use different type of diagrams with the same logic, because our goal is to go from the diagrams to the database. The inheritance, the multiplicity, all these exist in EERD and in class diagrams. Usually when we talk about class diagrams, we talk about object-oriented programming. We can talk about object-oriented relational databases also. This will not change also the logic. What we learn here, we can apply it in other domains also. In the previous videos, we talked about a class and an object. We talked about an entity and occurrence. And we said that one class, it represents a relation in mathematics. And one class or a relation in mathematics, it is represented by a table in relational databases. And the table, so the table, it is a generic. It contains columns. It contains sensor number, type, room number, height, etc., where we fix the sensor. But if we look at each line, it represents a real occurrence. So it represents an object in UML. And when we talked about databases, we said that we need what we call primary keys. And we said that the sensor number may be a primary key. What is a primary key? It is an attribute that should be distinct between all the occurrences. That means we should not have two rows with the same value of these attributes in the same column. For example, sensor number, we will not have in the table sensors, we will not have two sensors with the same number. We said that the primary key may be used as a foreign key in another table to make the correlation. This is the logic of primary key, foreign key. It is very useful to make the correlation. For example, we talk about some values that we receive in our Raspberry Pi. Some values are sent in a specific date from sensor number 1. If we want to know more about the sensor number 1, so we take this value and we use it in the table sensors in order to know more about these sensors. For example, we know that we received the value 21, it was the temperature, and it was in room number 3, and this sensor is fixed at the height of 150 centimeters. We can see that with SQL we can create these tables easily. The instruction is create table. So with the instruction create table, we can create these tables with all the attributes. For example, if we want to create the table sensors, we should say create table, the name of the table that we want, sensors. What are the columns in these tables? Sensor number, it is the first column. The second column, it is type, the type of the sensor. Third column, it is room number. Fourth column, it is height. And we can see that we said that the type of sensor number is integer, that it may have the value 0, 1, 2, 3, 4, etc. And it should not be null. The type of the type of the sensors is represented by 4 characters. So we can say temp, for example, for temperature, HUM, for example, for humidity, etc. It should not be more than 4 letters. We said that the room number should be integer also, and the height should be integer. We added here that the primary key is sensor number. So we precise here what is the primary key of our table. Each time when we create a new table, we should precise which column or columns represent the primary key. Also, we precised the foreign keys. So we said that we can go from this table to another table. The name of the second table is rooms. We precised it after references. We said that in this table we have a column. The name of this column, it is room number. It is a foreign key. It is related to the table rooms, to the column room number in that table. Using this instruction, even if we don't have the same name of the column in rooms and in sensors, but the database management system will understand that it refers to the same column. We precise that sensor number is not null. Also, type, it is not null. That means in all the lines of the table sensors, these two fields should be filled. Why these two attributes are not null and the others may be null? Think a little bit. You can stop the video in order to understand a little bit why we accept that sometimes these two columns may be empty. Because our database should take in account all the situation. Perhaps we need to add the sensors in our tables. After that, we will go to fix these sensors in a specific rooms with a specific heights. So when we will add the sensors in the database, it is not necessary to fix them in the rooms in the same time. If we go to the next table, we can see that we can create it with similar instructions. Create table sensor values, date time. It is from type date time. We should pay attention that the second date type, it is a type that is accepted by the database management system in order to represent the date and the time. We have a value float. Why it is float? The database management system accepts this type of data. It is float because what we receive from sensor, it is not integer. So we can receive 22.5, for example. What is important here that primary key, it is date time and sensor number in the same time. Because we receive data from sensors, we put them in this table. And we see that the primary key, it is not only one attribute. It is two attributes together. So in this table, we can know that in a specific time, a specific sensor give a value. If we choose only the date time as a primary key, it will not be enough because we may have two lines with the same date, because there is two sensors that send data in the same time. The primary key may be two values together. In object-oriented databases, the database management system creates an identifier for each object. A lot of programmers have the inhabit to add a column of integers in order to represent the number of the occurrence in each table. For example, the sensor number, the room number, the apartment number, etc. This may be useful, but we should pay attention because in some cases this may waste the storage media, especially if we have very huge tables. Also, to create the table, so we have the table sensor values. We can see that we add in this table, we add value index to the table sensors values in order to distinguish between all the occurrence, all the values of our table, and we will use it as a primary key. If we take a look to the general form of SQL create table instruction, we can see that it is really powerful. We have create table, we can specify the name of the table and the name of the columns. We can say that some columns are not null or it is unique. It is like a primary key. So we can precise all the unique columns in the table. And these conditions will be tested every time when we add a line. These conditions will be tested, so this will guarantee the integrity of our database. We have also default option. For each column, we can specify default option. If the user does not precise the value of this column, it will take the default number. We have also check conditions. That means we can verify each time when we add data or when we modify data that a specific column, for example, should be more than a specific values. For example, if we have a column related to the age of a human, it should be more than 0. Foreign key, we saw it before. On update, on delete, what we can do. For example, if we have a sensor in a room, if we remove the room, will we remove the sensor or not? If we remove the sensors, will we remove the room from our database? This is very important. This sequence of delete or sequence or of update, when we modify or delete or add some values, will this affect the other tables or not? We can specify that using this instruction or this part of the instruction on update, on delete. Which representation is better? Is it better to separate tables or to merge them together? For example, in the first table, we can see that we have sensor number 1, sensor number 2, and we have another table for the sensor values. In the bottom, we can see that we have one table in which we have the date time, we have the value, we have the sensor number, we have the sensor type, we have the room number, and we have the height in which we fixed the sensor. So which representation is good? Which is better? In the previous videos, we saw that the second form contained a lot of redundancy. For example, in the table that we saw last week, we saw that we have more than 60,000 lines. If each time we add this part, that means these data are repeated 60,000 times, and this will occupy the media storage. Imagine that we have a more complex situation. We have sensor values table that is related to sensors, and this table is related to rooms, and this table is related to apartments. Also, we can represent everything in one line, but it will not be smart because we will waste a lot of space and we will waste the integrity. Suppose that we will remove, for example, one room, one sensor from one room. To do that, we should modify a huge quantity of lines in this table. Suppose that we want to modify one sensor because it doesn't work. So we should modify this number on many thousands of lines in the table if we use this form of tables. If we have separated tables, we can modify only one sensor. What is the best solution? Usually in the science of databases, we try to make the table as pure as we can. We will not enter in the details, but after that, we can create different views regarding the needs of the users. For example, in our database, we can have the city manager who may use these tables, and the inhabitant, and the technician. Each of these users has different needs. For example, the city manager, he needs to know the temperature in this part of the city. For this reason, he needs, for example, the data, the date, time, the value, and the address. It is not important for him the number of the rooms. It is not important for him the height of the sensor in the room. It is not important for him the number of the sensor. The inhabitant, for example, he is interested by the temperature in the rooms. He is not interested by the number of the sensors in the rooms. So, and the technician, he is interested by the sensor because he wants to know if the sensor works well or not. So, from these tables, we can create, if we create a pure table, we can after that join these tables. We saw in the previous videos how we can join many tables together in order to generate a new table, a new view. We call this resulted tables view. What is the best solution? As I explained before, the design is not a deterministic task. So if we have two good designers, that doesn't mean they will have the same design, because each one has his own point of view. But we should know the positive and the negative points of each solution. It is important when we will create our tables to know the nature of the data that we will represent. For example, perhaps there is one sensitive data and we need to keep them separated from other type of data. We should pay attention to the source of data. Perhaps the source of data give us data with a specific form. We should pay attention to the size of data. If we have a huge quantity of data that come with a specific form, so we should pay attention to this type of data more than the other type of data. Frequency of production, user needs, as we saw in the previous slide. Frequency of consulting. If we have one user, like the city manager, for example, he wants to consult the data one time each year. He is not that like the inhabitant. He wants to see every time what happened in his apartment. So regarding our case, perhaps it will be a good idea if we create a permanent view, a permanent table to show the inhabitant what happened in the apartment. It is related to the nature of updating also, the frequency of updating. If we update specific type of data or delete a specific type of data many times, perhaps it will be a good idea to separate this data in order to protect the other parts of the data, etc. So we don't have a deterministic solution. It is not a magic. It is a logical discussion. The question now, how can we convert the relationships between diagrams into databases, into tables? The inheritance, for example, how can we convert the relationships between classes into tables? For example, we have this relationship, inheritance relationship between the subclass and the superclass. We know that duplex apartment, it should inherit all the attributes of the apartment. You know what is a duplex? Usually we put these sensors in social houses, in apartments, in residence, and some of these apartments are duplex. That means they exist in two floors with one entrance, but with a stairs inside, and go to a secondary floor. The duplex apartment has an apartment number, apartment owner, address, floor, basic floor, number of rooms in the first floor and secondary floor, and number of rooms in the secondary floor. How can we represent it? The first solution is to reuse the same structure in a new table, and we add new columns. You can see the added columns in red, and the added columns represent the new attributes. It is the first solution. This is the first solution. The second solution is to add the attributes, the common attributes, in the same table, and we will create a new table only for the additional attributes. But in this case, for example, the duplex apartment number 1 is related to apartment number 3. So we will see this in apartment number 3. We can see all the information related to the first duplex apartment. In the first solution, we had all this information in one line. In the second solution, we separated them in 2 lines. And we need here a foreign and a primary key to correlate between these 2 tables. So apartment number, we will use it as a foreign key in the duplex apartments, and it would be the primary key in apartments table. The third solution is to create a huge table, but we accept that in this table we may have some empty fields. So we create a new table with all the attributes, and we put the apartments in this table. Also, we can put the duplex apartment. Which solution is the best? It depends on the number of duplex. If most of our apartments are duplex, the third form is better, because we accept to have some empty fields. But if the duplex apartments are exceptions, so this solution will be bad. How we can convert one-to-one relationship? We have many cases. For example, we have a module that we may put in a room, and we have the room. So for this reason, we put 0 to 1. We can add a primary key in the first table, a primary key in the second table. How we can solve this problem? Will we correlate the rooms to the modules or the modules to the room? It is logic. I think it is clear that we will, when we add a sensor, in the table of the sensor, we will say that is connected to the fixed entity, that is the room. Another case, for example, we have apartment and we have water meters, 1-to-1. We know that general meter, water, we have only one in the house, and we have only one house. Usually, each general meter, we put it in one house, and each house, each apartment has a general meter. Which is the best solution? This case is not easy. It depends on our use. One of the solutions may be to add a reference in the water meters table to the apartment, and from the apartment to the water meter. For example, if we are in the water establishment, what is important for us is the water meter. So the apartment should be related to our water meter. If we create a database for the inhabitant, the most important for him is the apartment, and the water meter will be connected to the apartment. If we create a database for the water establishment, the most important for them is the counter, because they concentrate on the water network, and perhaps the apartment will be attached in their database to the water meter. If we create a general database, perhaps it will be a good idea if we make the 2 relationships. But this will create a complexity if we want to add a new water meter with a new apartment. When we convert a relation to a primary and foreign keys, we should pay attention to the integrity, so we should register the procedures that are needed in order to guarantee this integrity. One-to-many, where we will put the foreign key and the primary key. At the first, we will create a primary key for each of these entities. After that, will we connect the rooms to the apartment, all the apartment to the rooms? If we decide to connect the apartment to the rooms, that means we should have many lines in apartment regarding the number of the rooms. But the second solution is more logic. So we will create in the rooms table a foreign key in order to precise in which apartment a room exists. Many-to-many are more complex relationship. Why? Where we will put the foreign key and the primary key? So we have primary key. For example, the relationship between apartments and owners. We can have one apartment may have many owners, and one owner may share the property of different apartments. How we can solve this problem? It is not really a problem. If we remember the source of this representation, it can facilitate the solution. So each entity represents a class. It does not represent an object. Apartments, it is a group of objects. Owners, it is a group of objects. So we have a star from this side with a star from this side, because one apartment may be the property of different owners, and one owner may have many apartments or may share the property of different apartments. One of the good solution is to create a new relation, a new table. What we will have in this table, we will have the owner number and the apartment number. So each occurrence of this table, of this entity, will represent a part of the apartment that is owned by one person. So the occurrence will be clear. We simplify the occurrence. It is not an apartment. It is a small part of an apartment that is owned by a specific person. For this reason, we have two foreign keys, one for the owner and one for the apartment. And what is important, for each occurrence in this small table, we have a primary key. This primary key is combined from the two foreign keys. We can understand that better if we look at the table. For example, in the date of the 30th of January, the owner number 1 had a part of the apartment number 5. At the 30th of January, the owner number 2 also had a part of the apartment number 5. So the two persons had at the same date this apartment. At the 15th of February, the owner number 2 had a part of the apartment number 17. So each line, it represents a part of the apartment. This is a very good solution for many-to-many multiplicity. For example, we can see that the owner number 1, he is Charles Brown, and owner number 2, it is Emily Brown. So we can see that both of these people own the apartment number 5. This relationship is represented by this foreign key. Owner number here, we can see that it is the first line here. Also, we can complete it with the second table. We can see that the owner number 2 share the apartment number 17 with owner number 3. If we want to know more details about apartment number 17, we can go to the second line in this table. How can we convert the composition relationship? We remember that we used before our module with different type of sensors inside, and we represented it with composition. This is the symbol of composition. We are in our module, we have luminosity sensor, temperature sensor, acoustic sensor, and for each of these sensors, we have accuracy and sensor number. How can we convert this into relation, into table or tables? This is similar to one to one or one to many. The composition is a strong relationship, so we cannot separate these sensors from this module. One of the solutions, perhaps it is the good solution, is to create all of these in one table. We merge all these attributes on one table, so we can see that we have the number of the module, we have the temperature accuracy, we have the temperature sensor number, we have the acoustic accuracy, acoustic sensor number, etc. We can merge all these on one table. This may be a good solution with the composition. But if we talk about aggregation, with aggregation we know that the relationship is not permanent. For example, we can, with a mobile sensor, we can put it in one room, after that we can move it to another room, etc. How we can represent that? If we represent it with a merge table as in composition, it will not be a good solution, because each time we should move the relationship between a mobile and a sensor. One of the solutions may be to create a separate table for mobile sensors, and we make the reference to each room in the mobile sensor, but it will represent the eventual room. It will not be a permanent relationship. This may be changed. The room number may be changed. But it will be a good idea if we create a log file or a log table. In this table, we can precise all the rooms in which we put these mobile sensors. For example, we can say that the sensor number 1 from date 1st of January until the 5th of May was in the room number 3. Then from 5 of May till the 7th of July, we put it in the room number 9. In this video, we presented how we convert the diagrams into database. We explain how we can convert the inheritance, the multiplicity, one-to-one, one-to-many, many-to-many, the composition, the aggregation into databases, and how we can create the tables, what are the instructions that we may use in SQL. We can use the same logic to create any other type of databases. Hope you understood this presentation. Don't hesitate to add any comment or question. If you don't understand everything, please add your question in the comment and I will answer to it.